The sum to infinite terms of a geometric progression is given by S, and the sum of the squares of its term, that's S1. So we need to show that the first term and common difference are given by these two expressions. So let's begin. First, we'll have to specify the first term and the common ratio of the infinite geometric series. So let them be, let A be the first term and R in lowercase be the common ratio of the given infinite geometric series. Now, it's given here that the sum of the terms, that means A plus AR squared all the way up to infinity, this is given by the sum S, and the sum of the squares of each term, so we have A squared plus AR whole squared plus AR squared whole squared, so this sum is given by S1. Now we know that sum to infinite terms of a geometric progression, that's given by the first term divided by 1 minus the common ratio. So this is the value of S. Then we have this in another infinite geometric series with the first term A squared. So we have A squared divided by 1 minus the common ratio R. So the common ratio in this case will be AR whole squared divided by A squared. So that will be R squared. So this is equals to S1. Now what we'll do? So we will square both sides to get A squared divided by 1 minus R whole squared. So this is equals to S squared. Right. So let this be equation number. So this is equation number 1. This is equation number 2. And let this be equation number 3. Now let's divide equation number 2 with equation number 3, which is going to give us A squared divided by 1 minus R whole squared multiplied to 1 minus R squared divided by A squared. So that will be equals to S squared divided by S1. So here A squared and A squared gets cancelled. So 1 minus R squared can be also expressed as 1 minus R multiplied to 1 plus R. Divided by, we have 1 minus R whole squared in the denominator. So this is equals to S squared divided by S1. So 1 and 1 minus R from the numerator and 1 from the denominator cancels out. So this leaves us with 1 plus R divided by 1 minus R. So that's equals to S squared divided by S1. Now we can use the method of componendo and dividendo. So here, now the componendo and dividendo says that if we have the ratio A over B equals to another ratio C over D, then we have A plus B divided by A minus B. So this will be equals to C plus D divided by C minus D. And that means we're going to get 1 plus R plus 1 minus R divided by 1 plus R minus 1 plus R. So this is equals to S squared plus S1 divided by S squared minus S1. So in the numerator, R and negative R goes away. In the denominator, 1 and negative 1 goes away. So we're left with 2 divided by 2R. So that's simply 1 over R. So 1 over R is S squared plus S1 divided by S2 minus S1. Taking the reciprocal on both sides, so R value will be equals to S squared minus S1 divided by S squared plus S1. So we've successfully proved that the common ratio is indeed given by S squared minus S1 divided by S squared plus S1. Now our next task will be to obtain the value of our first term. So let's use equation number 1, which is S equals to A over 1 minus R. So we're given S equals to, so this is equation number 1, A divided by 1 minus R. So we want to obtain the value of our first term A. So we have S multiplied to 1 minus R, which will be S multiplied to 1 minus, so R value is S squared minus S1 divided by S squared plus S1. So let's perform the calculation. So we'll combine the common denominator will be S squared plus S1. In the numerator we have S squared plus S1 minus S squared plus S1, which will be, now S squared and S squared gets cancelled. So we have 2 times S1. So this is going to give us 2 times S1 divided by S squared plus S1. So this is the first term, which is also now proved.